So I'm going to give you a whistle-stop tour of the pilot study that we have been developing over the last 1 year or so at Cambridge. Um, so this is the West Cambridge Digital Twin Pilot. The objective really for us is to see how can we actually develop a digital twin and move towards developing a national digital twin that aligns with the messages, the principles, and the core values that are represented by the Gemini principles. So for us, initially, the objective is to develop this dynamic digital twin. So this digital twin is not just a static model, it is not just a 3D model. As Mark was saying, it is about understanding how we can develop a digital twin that represents the current status of the asset and the assets that we are actually managing. So how do we develop a dynamic digital twin of the campus and demonstrate value from that digital twin, demonstrate its impact on, say, for example, facilities management, but also wider productivity, well-being of the people who are working and living in that campus. We are working with a number of industry partners, as you can see there, and we are exploring how we can get more and more industry partners involved in this activity as well. So why are we doing this? I did mention that there is a demonstration purpose. We need to figure out how we can actually do this, of course, but hopefully this will provide the foundation for developing city-scale and wider national digital twins. We can use this pilot to really understand what the key message that Mark said. In order to develop a national digital twin, we need to enable secure interoperability of data. So how do we do that? And one of the activities for or the objectives for this pilot is to figure out how that might be possible to do. And finally, this is not for Cambridge to play around with. Hopefully this digital twin pilot, we would be able to open it up to the wider research community so they can then use this digital twin as a way to improve, do further research, develop new applications, and help us even get this even better. So what are the key activities, work strands that this pilot involves? First of all, we need to get a current understanding of what assets we have, what data we can collect from the assets. So there is a big data acquisition activity that's going on. Once we get the data, we need to integrate this data, pull these different data streams from different assets and different systems together. We need to demonstrate value, so there is a piece of activity that is focused around application development. And of course, we need to actually figure out what is the appropriate data model that will help enable this secure interoperability of data. So just going into a bit of detail, we have started off with our own departmental building, and the plan is over the next year and the next couple of years to expand out into the wider campus, include more and more buildings, include more infrastructure, utilities, and so on into this digital twin. So inside the building, we have deployed a number of IoT, Internet of Things, sensors that capture information about temperature, humidity, occupancy, and so on of the environment within the building. For specific assets, for example, for the HVAC systems, the pumps inside the building, we have started capturing condition information through, say, for example, vibration monitoring sensors. In addition to that, to identify the assets that we have worked with a partner called Redby to deploy 2D barcode systems which you can actually interact with. You can use these 2D barcodes to interact with the assets. You can scan the barcode, and on the phone, a profile of the asset will come up. You can enter data. If you're a maintenance provider, you can enter data about the maintenance activities that you've carried out, and all of this will be then integrated with the university's facilities management system. And then we are pulling all this data together as well. So other than the sensor data and so on, I did mention that, we have the usual suspects, BIM model. We need to have a 3D BIM model of the building. In addition to the BIM model itself, we're working with partners like Bentley, Topcon, and Geoslam to get data on the actual reality models as well. So point cloud data across the site, specific detailed 3D scans of specific areas within the building, and so on, which will give us a richer picture of what's there inside the building. The challenge with the 3D scans and the point cloud data is then to identify the objects automatically from these scans, and that'll form as part of our research activities. I did mention the other sets of data that we are collecting. So there's a lot of data acquisition that we are going through. And it's a blank slide that says data integration. Yes, it has come up. So what are we doing with all this data? We are pulling this data together in different forms. So the sensor data and the building management system data is uploaded to an Amazon Web Service cloud. The other data that we are collecting, the asset register, the facilities management system, and so on, they are opened up through APIs, and they are all brought together to these platforms. So there are a couple of platforms that we are developing. One is developed by our partner Bentley. So they already have the capability to use all this data, display all this data, and use analytics to draw insights from this data through their Amulet and AssetWise software. So we're using that to show what the state-of-the-art capability is. And on top of that, we have developed another platform where we can actually draw in the BIM models and do other sets of analytics together. And those analytics are provided by this application platform that we are developing. Just a snapshot of a couple of snapshots of the platform. So this is the one that is being developed by Bentley, where depending on which room you are, so you have selected within the building, it shows the appropriate sensor data that we are capturing in that room. This is the other platform that we have. This is a 3D BIM model through IFC. What we can actually link to is again, the sensors that are within that building. For example, if a particular room is too hot, it will highlight that to the facilities manager that it is actually too hot. The facilities manager can then dig deeper into the root cause of that problem. So we've got a fault diagnostics algorithm that sits behind it and says the temperature is too hot because of these assets that are not working properly within the building management system. So we can not only just display the information from these assets, but also do some useful insights and analytics on the basis of that. We are developing a number of apps that will help us deliver value from this digital twin. So, for example, a failure prediction algorithm, anomaly detection algorithms that will detect if things are going wrong, use the data about failures and the costs and risks and so on, and determine the most effective maintenance plan and the maintenance prioritization plans and so on. Use of emerging technologies like augmented reality. How can this help in delivering better maintenance, more effective maintenance? How can we optimize energy usage in this building if we are collecting data about energy usage from buildings across the campus? Where we want to move to with a wider campus-wide digital twin, and hopefully with a city digital twin, is integrate that with wider city traffic models. Ask questions like, if we build a new building in this campus, what is that going to do to air pollution level? What is that going to do to traffic levels? What should the city council do in terms of putting in new public transportation routes, and so on and so forth. Last off, we also need to do this properly, so understand the data models that will support this secure interoperability of data as well. So we are looking at a wide variety of standards that includes IFC, and look at the role that these standards play in making the digital twin a reality. Looking ahead, of course, we want to move out of just looking at individual assets and look into large-scale systems. Demonstrate how plug and play can be achieved. For example, today we have a digital twin of one building. If you have a 3D model and a digital twin of another building that someone else has developed, how easy is it just to plug it into the campus digital twin and make it just work? It's not possible today. So we want to understand how we can actually make that possible. And of course, at the large scale city and national level, how can all this, what can we learn from this pilot study that will support the idea of that national digital twin? Thank you.